Evaluating an exponential function that models a real-world situation. If the rate of inflation is 2.5% per year, the future price, P of t, in dollars, of a certain item can be modeled by the following exponential function, where t is the number of years from today. So t they're using to represent time in years, okay? Find the current price, or the P, of the item and the price 8 years from today. Round your answers to the nearest dollar as necessary. Okay, so we have an exponential function here. What we need to remember about exponential functions is that the function P of t, or I would even change this to f of t, just in general terms, f of x, let's say, of any function is you have one constant. We're just going to use a little a to represent that constant. And then you have another constant with an exponent on it. And this is actually the variable, okay? These two are just numbers that aren't going to change, or constants in the equation. And you can kind of think of these two numbers. The a, this first number that you see in your equation, is your start value. Or you could think of it as how much do you have right now, or how much do you have to start. In a lot of situations or problems, it'll be called the initial amount. This one, this particular problem, is referring to this a value as the current price, okay? The start, or how much do we have now, right? In this problem, that's the current price. And then the b is or the second number is the number that represents the change. How much are we changing, okay? So we're starting with this number, and then how is that number going to change over time? And in our problem, it is the rate of inflation, okay, is 2.5% per year, okay? So if we look at our equation right here, my current price would be the start value, the a, the number in the equation that does not have the exponent on it. And if we look at that in our equation, that would be 2,000. So the current price for our problem is $2,000. Okay, that number right there. It's the start, or what it's worth now, okay? Now, the change is modeled by this number right here. And this 2.5% that it's giving us in the problem, you can see that right here as the 0.025. So the 1 means we're keeping 100% of the value, okay, or the price, and we're adding another 2.5% to it, okay? So when they ask us to now find the price of the item 8 years from today, that means they want us to evaluate our function for 8, or find the price of the item 8 years from now. So we're just going to substitute an 8 in everywhere we see a t, okay? So it will be $2,000. So the item is starting, right, at a price of $2,000 now. That's what it's worth now. It's going to gain value because we're going to keep 100% of the value plus gain another 2.5% of value. And it's going to do that every year for 8 years. So the 8 goes in as the exponent. They have it on the inside of the parentheses. I wrote it on the outside. It doesn't affect the answer at all. So now we're just going to type that into our calculator and evaluate it. Okay, and get our value. So 2,000 times 1.025 raised to the 8th power is going to give us 2,436, and they asked us to, let's see, round our answer to the nearest dollar. So I have to say to myself, is this closer to $2,436 even, right? Or $2,437? So this 80 cents right here puts us closer to the $2,437 as my final answer. So current price right now, it costs $2,000 in 8 years. It will cost $2,437.